Everything working? I posted that to the right place, right? Oh no, god damn it. Mess. Just fuck something up. So I'll go ahead and schedule the COP2 meeting. More confused by that announcement than I should be. It's accidentally the COP1 link, so I swapped it. Yeah, alright. Sweet. Alright, hey guys. So a few things that need to be explained. Very sorry for having to change our plans so last minute, but if you read the Canvas announcements, and since you're here, I'm assuming you have, probably understand well enough. Switch over to the cam here. Basically, there's a technical issue with WebAssign and HonorLock that I was unaware of. It was something that that wasn't present last time I tried to use them together, but one of you guys reached out to me and said, hey, last time I tried to do this, my professor had this problem, and it created chaos for everybody. So wanting to make sure that I did not create chaos for everybody, I called HonorLock's tech support yesterday and asked them. And at first they were like, oh no, there's no problem like that. Yeah, it's all fixed, it's all good. And then I asked him to please just let me talk to one of the developers for a minute because I wanted to make absolutely sure. And the developer was 100% straight with me. And he said, oh, no, yeah. If you're using Canvas for your LMS and you're using WebAssign for your exam platform, and you want to try and launch proctoring with HonorLock out of Canvas for a WebAssign test, it absolutely will not work right now. So we can't do that. What I'm doing in place of that is writing the test in Canvas. It takes a little bit more time, but I think that the product will actually be a better product. The test will actually be a better test. So it's got ups and downs. And for you guys, I think it's all ups, right? It's going to be a better test, and it's giving you a little bit more time to study, and there's no confusion with WebAssign or anything like that. There are some little peculiarities with Canvas, namely the way that Canvas would like to have you scan and submit your work is not the way that I want you to scan and submit your work. But it's going to be very, very simple. So here's the deal. I'm going to create a quiz in Canvas titled Exam 1. And that quiz is going to have some true-false questions, some multiple choice questions. You'll get feedback on those right away. It'll tell you as soon as you submit your test whether those were right or wrong. And those will count for a little less than half the grade. The remainder of the grade will come from what are going to be essay questions in this quiz. So those will be free response questions. Something like, find the equation of the tangent line to this function, or tell me where that function has horizontal tangent lines, or calculate the derivative of this function. Things that we've been doing, all the same sort of things we've been doing. And I'll take the question styles and try to have them mirror the styles that you've been practicing in the study guide so that things don't seem foreign or scary. But there'll be things that have very, very simple answers, like a numerical answer, just one number, or an ordered pair that you can type right there. In the answer field for the essay question, you will type your answer, whatever, that ordered pair or the equation of that line. But then after you finish the test, you're going to scan all of your written work. So the rules for having to write out solutions to each problem still very, very real. You have to scan all of your written work for all of the free response questions and then submit them under the assignment titled Exam 1. So the same place you were going to go to submit your written work for the test, you will go to submit your written work for this test. The only difference being, instead of doing the other portion in WebAssign, you will do it in Canvas quizzes. So there are going to be 5 true false, multiple choice, and like 7-ish free response. Canvas calls these essay questions. These guys, you don't need to show work for these. And they'll be graded automatically. So last night I spent a bunch of time just experimenting with the Canvas quiz features and seeing what sort of things we can do. This seems to be the best way to do it. The 7 free response, these you'll enter your final answer in the quiz as you take the test, as you go. And scan and submit work once complete. And the written work is every bit as important for this Canvas quiz thing as it would have been for the WebAssign thing. you can probably guess why I'm asking you to do it exactly this way. So you need to type your answer in Canvas as you solve the questions so that I know that the answer that you entered into Canvas corresponds with the work that you submit to me after you finish the test. It's important that we have that kind of double verification thing. I can't just have you scan and submit work and not type an answer in Canvas. Conversely, I can't just have you type an answer in Canvas and not scan and submit your work because I need to know that you did the work and that your work led to your answer. So it should be simple enough. And if you get nervous or you're worried about something going wrong or you have questions, anything at all, I'm happy to talk about it. So what's on your mind? What are we thinking? Is there anything about this format that is unclear?
I have a question.
Yeah, what's up?
Will we be trying to like map graphs on the canvas?
I don't intend to make you graph anything on the Canvas, like inside the Canvas quiz. No, I haven't seen any way to do that, honestly, to make you draw things. Did you say draw graphs or match graphs?
Like draw. I know because when I would do the homework, I would get stuck on like all of the buttons and all the options. It was just very hard to draw the graph. Like I could do it on the paper, but it was so hard to get the thing to work with me.
I don't at this moment in time have a way to make you draw graphs in Canvas, and I wouldn't want to implement something that is complicated in that way. Like, I don't want you to burn time trying to figure out how to do something during the test. So right now, I don't plan on making you graph anything in Canvas. There might be some problems where I ask you to sketch a graph in your written work, and then the graph that you sketch would be scanned and submitted with your written work, but I don't intend to make you graph anything like electronically.
Okay, thanks.
Yeah. Carlito sent me a question. How would I test you on the true false? Could I ask you to clarify that a little bit? Just the question, what exactly is it you mean?
Are you gonna ask us, is this the definition of a limit, or is this the formula, stuff like that?
Questions like that aren't totally implausible, but usually my true-false questions are a little bit more concept-focused. Like, is this function differentiable at this point? Or is the slope of the tangent line to this function horizontal at this point? Or is this the equation of the tangent line for this function at this point? Stuff like that. Things that either lean on a skill you've practiced or on a theorem you've used. So I could ask you, is this the correct value of this limit? And then you could calculate the limit and answer, yes, it is true, or no, it's not, false. Something along those lines.
Okay, thank you.
Yeah, of course. So while we're there, the scoring. So the true false are worth 2 points each. The multiple choice are worth 3 points each. And the free response are worth 5 points each. And in order to get full credit on the free response, I want to make sure I'm super clear about this. You have to have the correct answer typed and correct work scanned. So the work here is every bit as valuable as the correct answer. So the way it shakes out, the free response is worth a little bit more than half the credit on the test usually.
Would you take points off if we somehow forgot to simplify the answer?
That's a good question, and I have a pretty carefully tuned nose for this stuff at the Calc 1, Calc 2 level. So if, for example, you were to give me something like tan inverse of 1 and not simplify this, to pi over 4, Or if you were to give me something like 1 divided by 1/2 and not simplify to 2. These are the sort of things that I might take off a half point for if they're important in the context of the question. So little algebra simplification things, I would only take points off if that results in something not working the way it should later in the question. As a general rule, if your response and your work are both correct, then I want to give you full credit. In some instances, things like this not being simplified to their much, much simpler forms can create havoc down the line. And if that's the case, then those are half-point mistakes. But for the most part, no. For the most part, I don't really care whether you simplify something or not, as long as it doesn't cause trouble down the road. So like if you were to come up with an equation for a tangent line, and I was to ask you for the y-intercept down the road, but you don't put the tangent line into mx plus b form, so you can't read off the y-intercept, you read the y-intercept off incorrectly because you didn't simplify it into that form, then I might take off a half point for not simplifying that answer. So stuff like that, right? Stuff like that. So only if it hurts you down the road, only if it's an obvious simplification that someone at this level should be making intuitively and quickly.
Okay, so like when we're doing questions on the trig and we like forgot that we could simplify with because of identity, then if we just leave it as the answer, and that's fine.
Again, depending on whether or not it hurts you down the road. So if I asked you to cook up the derivative of the tangent function, and you were to give me this guy as it shakes out, which simplifies, of course, to 1 over cos squared theta, which is secant squared theta. If you remember that calculation where we found the derivative of tangent, if you were to give it to me like this, I might dock you for that. I think looking at it, and it's something that I would have to see in context. I would have to see what the rest of the class did. I would have to have my rubric, right? And I don't have a rubric prepped for this test yet because I haven't finished writing it. But mistakes on this level, failure to simplify on this level, usually around half-point mistakes. The use of the trig identities and the use of kind of the fundamental algebra and knowledge of the unit circle, those sort of things we do need to know. And an inability to do that is the sort of thing that I would have to dock small amounts of points for. But again, what I'm looking for is the overall skills, the strategy, the problem solving. So if it's a small part of the problem, probably not any penalty. If it's a significant part of the problem, then a small penalty would apply.
Okay, thank you.
Of course, of course. Yeah, Angelica, so I got a few questions in chat here. I remember that problem. We actually looked at that guy on Wednesday a little bit. And there's that full angle identity, there's a strange thing. That's not the sort of thing I would dock you for. So the identities that I definitely hold you guys responsible for are the Pythagorean identities, for sure. Gotta know those. All 3 of them, gotta know them cold. And then for us in this class, the double angle identity for the sine function is very important, but really the double angle identities I would not consider as fundamental or as crucial to know quickly as the Pythagorean identities. So if you were to stop a little bit short of a final answer because you didn't see a double angle identity, I don't think I would dock you for that. But definitely the Pythagorean identities are the sort of things that I would penalize for because we need to have those handy. Remind me in just a minute and we can take a look at that problem again really quick. Other questions I'm getting in chat. Zach asks, what kind of calculators are we allowed to use? That's a good question. You can use a 4-function calculator, right? Add, subtract, multiply, divide. but nothing else. No graphing calculators, no calculators that can evaluate trig functions exactly. If you have a simple scientific calculator that is able to say, like the sine of, whatever, let's say the sine of pi over 4 is like some decimal. That's okay. If you have a simple 4 function or simple scientific calculator that tells you that the sine of pi over 4 is exactly the square root of 2 over 2, that's not okay. Right, so this is where I draw the line. I don't mind you having a calculator to check your arithmetic. I understand that it can be a reassuring thing and it's hard to get used to not having that. But for example, you need to know your unit circle. And you need to be able to evaluate logarithms and exponential functions by hand. So those sort of calculators are not kosher. I think the TI-30X is of the type that I'm talking about, but I'm not 100% sure. Let me take a quick look. I have a sneaking suspicion, actually, that this does return exact values, but let me see. Sorry, forgive the YouTube video. No YouTube.
Hello and welcome to HP Calcs. I'm Rick, and today we're going to have a quick look at how to use trig functions on the Texas Instruments TI-30.
Okay, no. So this, shoosh, goddamn.
And press equals. And we see we get a cosecant of 30 degrees is equal to 2.
Mm-hmm. Okay, yeah, no, this is fine. Yeah, so TI-30X is fine. So like I said, as long as it's not giving you these irrational values exactly, it's giving them as decimals, I'm okay with that. Point being, if you needed the sine of pi over 4, I need this. I don't really care about the decimal. If you were to shoehorn a decimal in there because you forgot your unit circle, I wouldn't hurt you bad for that. That's like again, like a half point thing. But I don't want us to be leaning on those, right? So the kind of fundamental skills from pre-calculus and trigonometry, we need to see that those are present here in Calc 1. So good questions. I'm glad we're having the time to discuss this. Other questions on the exam? So sometime over this weekend, I will make another Canvas announcement, kind of like the how to take exam 1 announcement I made before. I'll make another one of those that's modified a little bit for this, explaining exactly where to go in Canvas and exactly what to do, because we will need to be running honor lock. That's the whole point here. And I don't want to muddy the gradebook too much. So rather than trying to stuff the exam into the existing exam slot in the gradebook, I'll be creating a quiz in Canvas. And I don't want anybody to get confused between the two things that have the exam 1 title. So definitely before the test on Monday, make sure you have carefully read the follow-up announcement explaining exactly how to take the exam. And if there aren't any other questions on the exam protocol, then I would be happy to spend the rest of today solving some more practice problems. So is there anything that we didn't get to on Wednesday that you guys would like to take a look at, or anything that you were hoping to look at in office hours that we weren't able to? Anything like that? What would we like to look at? Or if there are more questions about the exam protocol, we can answer those too, of course.
Back to the root 2 over 2. I'm confused. Are we not supposed to have that as an answer, even though that's the exact value?
no, you are supposed to have this as an answer, and you're supposed to know it on your own, right?
Okay.
So this is what I want, and it's important that you supply this, not the calculator. All right. So calculator saying.
Oh, I'm just confused why it says not okay for that part.
So if you have a calculator that would return this, you cannot use that calculator.
Oh,
For
okay.
this yourself, right? So the question was, what kind of calculators are allowed? And the answer is, you can use a calculator that returns these things as decimals, but you cannot use a calculator that returns the exact values, because I want you to use the exact values and I want you to supply them, not a calculator. So there are some scientific calculators, I've seen these, that will return the exact values. Those are not allowed because I want you to know your unit circle. I want to know when I see this on your page that it's coming from you, not from a calculator.
Okay, thank you.
Okay, so yeah, Sergio, I'd be happy to talk with you a little bit more later. Maybe send me an email. I know I'm not like turning emails around the fastest in the world right now because I got so damn many of them, but I can give you a nice thorough answer to that question via email or in an office hour. For sure today, well, we will continue solving some problems. It looks like Angelica specifically wants to see number 17 from homework 5, so we will start there. Sorry, let's get out of this. Oh, another little note here, WebAssign is apparently going to be down on Saturday from, I think they said like 2 a.m. to 7 a.m. or something. Did I push these? I need to push these too.
That's prime time.
What was that?
2 a.m. to 7 a.m. is prime time. Shut down.
Yeah, it's funny. I'm grateful that they have devs that are willing to work at night rather than during the day, but just a heads up, if you do try to access it during that time.
No, yeah, that's super helpful because that actually is when I do my work. Believe it or not.
No, yeah, I mean, I'm like that sometimes too. Sometimes it's just easier to work at night. Okay, so homework 5 and the study guide are now due on Monday at the start of class, and we will take a look at that problem from homework 5. Okay, so this coming from section 3.2, we can use our quotient rule here. We don't need to use the limit definition of the derivative. We can jump right in with our quotient rule. So let's do that.
Can we just know that the square root of x is 1 over 2 root x?
Yeah, if that's something that you have stored away in your brain, I don't have a problem with that. I certainly have that stored away in my brain and often do that quickly. But I would caution you against memorizing too much. Make sure that you leave enough space in your brain for the shit that you need to remember. It's not too hard to cook up. But so this is like my F, and this is like my G, and we know that F over G, all primed, is the bottom times the derivative of the top, G times F primed, minus F times G primed, over G squared. That's my quotient rule. So we'll be applying that here, f primed, like Angelica said, we can differentiate this thing as x to the 1/2 all primed, right? The square root of x, f of x is the square root of x, that's x to the 1/2. So that's what I want to differentiate. And if I use my power rule here, I bring the 1/2 down, and then I'll have x to the 1/2 minus 1, which is 1/2 times x raised to the 1/2 minus 1 is negative 1/2. So that's the same as 1 over 2 times x to the 1/2, which is root x. And some people do just memorize this as the derivative of the square root function. My suggestion would be to differentiate it enough times that it becomes like a muscle memory thing, so you don't need to actively commit memory on it. The other derivative we need here, g primed, is the derivative of g is the derivative of 9 plus x. This is a little simpler. The 9 differentiates to 0, and the x differentiates to 1, so g primed is just 1. Therefore, my derivative, that's g times f primed, so that is 9 plus x times 1 over 2 square roots of x minus f times g primed, that's the square root of x times 1 all over g squared, that's 9 plus x all squared. And while we're asking questions about simplification and expectations, I would be okay with this as it is, right? I would not mark anything off or say that this is insufficiently simplified, unless we were trying to find horizontal tangent lines for this, where we would need to then set the top to 0. And if that's the case, then you would need to simplify because you're not going to be able to handle that as it is.
Yeah, simplifying after this point is where I racked my brain. But this is great news that that's a good answer.
It is. If it's just to differentiate and not then do anything with that derivative, this would be a fine answer. But just for fun, let's see how we could simplify this. So my numerator has this fraction in it, which tells me I need to rewrite my whole numerator as a single fraction, i.e. I need a common denominator between these two pieces, and then I'll be able to play flip and multiply games. So I'm going to rewrite my numerator as 9 plus x over 2 square roots of x minus the square root of x to start, so we can kind of get a feel for the strategy. And then we'll see that to clean the thing up, I need a single fraction upstairs. And the way to do that is to write this guy as a fraction with this denominator. So he needs to get multiplied by 2 root x over 2 root x. Then what I end up with is my 9 plus x over, I'll write it like this still, over 2 root x minus 2 root x times root x. That's 2x over 2 root x. And now my numerator is written as with a common denominator between the two terms, so I can combine them. So that's 9 plus x minus 2x all over 2 root x. And then that whole apparatus is being divided by 9 plus x squared. And I'll take this up here next. I've got some like terms I can combine. The plus x and minus 2x makes a minus x, so that's 9 minus x over 2 square roots of x, all divided by 9 plus x quantity squared. And now I can do my whole flip and multiply thing. So the numerator is this fraction, so I'll leave him alone. And then I want to divide him by this, which I think of as this over 1. So I get 9 minus x over 2 root x times 1 over 9 plus x quantity squared. And that gives me this, my fully simplified form. So yeah, if I just say find for me the derivative, you can stop here. That's all right. But if I said find the location of any horizontal tangent lines, you're going to need to get here before you can really get things done, because you need to know how to solve this thing equals 0, which is a somewhat complicated thing to do, especially if you're looking at it from this level. So this sort of algebraic simplification is going to be important in the class, especially when we get into chapter 4 and we start talking about applications of the derivative, where I make you solve inequalities and equations involving derivatives. There are some tricks for shit like this. Here you see me going through things the long way. It's the intuitive way. But there are some algebra tricks that can be useful for simplifying expressions that have this sort of shape. And one place you can find those tricks. This thing. So calculus, again, not necessary. None of this necessary. You can do things the way I just did them. But if you're looking for tricks or supplemental stuff to help you get better at the algebra and trig that is involved in calculus, I have not yet met a better book than this one. Try to find it at the library. I don't know if the Santa Fe Library or UF Library or Alachua County Libraries have it, but I would expect that at least one of them does. If not, there are some used copies of this that are not too bad. You might consider grabbing one. I used to have one, but I lent it out and never got it back. So this particular book has a lot of really great tricks on how to simplify expressions like that. If you want tricks like that but don't want to look for that book, send me a Canvas message and I'll try to find some similar free resources. But you can always do this, right? I mean, follow your nose, do the stuff you did in pre-calc. It all works great. That's the point of pre-calc. Questions on this guy? Okay. So, unless anybody else has any specific requests, I'm going to move to Angelica's next problem, which was 23. Yeah, 23 is actually a good problem worth doing. Carlito asks a good question in chat. So before I solve 23 here, suppose I ask you for a derivative using the limit definition and you panic and forget and just use the power rule or product rule or something else instead. That would be a significant doc. So again, I haven't written a rubric for the test yet, but that would not be a half-point mistake. That would be a 1 or 2 point mistake probably on a free response question. I think if you were to differentiate correctly, but the whole problem was give me the derivative using the definition, then that would be like a 2.5 point mistake, something like that, because the limit definition of the derivative is definitely something that we are testing on this exam, and it is something that you should know. Now, if you were to try with the limit definition of the derivative, you write down the definition and you get started, but you get stuck with the algebra, and so then you go off to the side and differentiate using the power rule or whatever, that's a different story. That's not going to be 2.5 points off. Whatever portions of the correct solution you gave me, I would give you credit for. But then there would still, of course, be some consequence for not following through correctly. Now, good news is I'm not likely to ask you that straight up, right? I'm not likely to straight ask you, use the limit definition of the derivative to calculate this. But what I might ask you is whether or not a function is differentiable at a point. This is the second time I've made this comment today, so you can kind of guess that it's coming. So remember how to show that a function is or is not differentiable. That's a big deal, and that's the sort of thing I would use to test your knowledge of the definition. So showing me that that limit doesn't exist for this function at this point, something like that.
Can you show us an example of that?
Yes, thank you.
Sure. Yeah. I mean, I don't want to give too much away. It would not be a. Yeah. Sure. Sure. All right. First, let's do this.
Thank you.
Okay. Yeah. I don't mind reminding you how those go. But before, we're gonna do this guy. Okay, so we want to find the derivative of x squared sine x. This is a product rule thing. So I kind of think of this as f and think of this as g. And I remember that f times g primed is f primed times g plus f times g primed. So my derivative, this is the product rule, that's x squared times sine of x all primed. That should be x squared primed times sine of x plus x squared times the sine of x all primed. And so the first piece there, I can use my power rule. This is 2x to the 1, or just 2x times the sine of x plus x squared times the derivative of sine is cosine. We can factor an x out, and we might as well. But again, this would be okay. So a free response question, ask you for this derivative, you can stop here. If you wanted to do something with it, I would recommend factoring that x out, and you get 2 sine of x plus x cos x, like this. Okay, I did see in chat there's a couple other problem requests. I will get to those in 1 second, but we wanted to see an example of the type of question I might ask you to use the limit definition of the derivative on the exam.
So when I get frustrated, just stop, basically, is what I need to do.
Regarding simplification of a derivative,
Yeah.
If there's nothing else you need to do with the derivative down the line, yeah. So better to be correct, right? That's the idea. If you think you might make a mistake in the simplification and you don't need the simplified form for anything else, better to stop before you wander into unknown territory and make an error. So I would rather have a correct derivative that's not fully simplified than an incorrect derivative that looks nice. Does that make sense?
Yes, thank you so much. I'm
Of course, yeah.
really stressed so much. Thank you.
I know you guys have been working hard, and as long as you've been putting the time into the homework, I assure you, it will be okay. So something, use the definition of the derivative to show that f of x equals the absolute value of x minus 2 is not differentiable at x equals 2. Right? This would be an example of a problem like that. So the basic idea here, the intuition that we have is that we know the graph of this thing looks like this, right? And it has this hard corner here at x equals 2. So the graph isn't smooth there, which means that we don't expect the function to be differentiable, but we need to use the definition of the derivative to show that. So if it existed, f prime of 2 would be equal to, the more convenient definition to use here is this one. This. So what we're going to do is we're going to show that this limit doesn't exist. And here's the basic idea. If you look at the limit as x goes to 2 from the left of f of x minus f of 2 over x minus 2, what you get is the lim x to 2 from the left, absolute value x minus 2, that's f of x, minus f of 2 is 0 over x minus 2. So this is the lim as x goes to 2 from the left, abs x minus 2 over x minus 2. Since I'm taking the limit as x approaches 2 from the left, the absolute value of x minus 2, I'm thinking about plugging in numbers to f of x that are a little bit smaller than 2, which means that I'm plugging in over here, which means that that function has slope -1. In other words, the absolute value of x minus 2 is really negative x minus 2 over x minus 2, like this. Because we're coming in from the left, you have to remember the definition of the absolute value function to make this go. Remember, abs x minus 2, where can I put this without cluttering things? Absolute value of some stuff is a piecewise function. That is, that stuff, if that stuff is greater than or equal to 0, or negative that stuff if that stuff is less than 0. So the absolute value of x minus 2 is x minus 2 if x minus 2 is positive, that is if x is greater than 2, or negative x minus 2 if x is less than 2. So since I'm looking at the limit from the left, the x's I'm considering are less than 2, which means the absolute value of x minus 2 is negative x minus 2. And so this limit you can cancel the x minus 2's and you just get -1 over 1, which is -1. On the other hand, the limit as x approaches 2 from the right of f of x minus f of 2 over x minus 2, that's the limit as x approaches 2 from the right of absolute value x minus 2 over x minus 2. That's the limit as x approaches 2 from the right. Oh, where are we? Sorry. Here we go. So here's my left-hand limit. He comes out to -1 because as I approach 2 from the left, the absolute value of x minus 2 is negative x minus 2. That's coming from the definition of the absolute value function. Or you can think of it as coming from the graph, right? For x is less than 2, this function is has slope -1 and y-intercept +2, so you know that it's -x plus 2, or with the negative factored like this. I encourage you to think about it as coming from the definition, though. On the other hand, if I'm coming from the right, this function has slope +1 and intercept -2. In other words, as x approaches 2 from the right, or if you plug in any x's which are larger than 2, the numerator here, the absolute value of x minus 2, is just x minus 2. And that's the limit as x approaches 2 from the right of 1. Which is 1. And these aren't equal. So I would wrap up by saying since the limit defining f primed of 2 does not exist, and that's because the left limit is not equal to the right limit, the function f of x equals abs x minus 2 is not differentiable at x equals 2. That's the game. So there was at least one problem like this. I think probably just one problem like this, but at least one problem like this back in the homework where we first met the derivative. It was one of those like master it problems in WebAssign where you had to walk through little steps and input things into boxes to show that the limit defining the derivative does not exist, and then conclude that the function is not differentiable at that point. And that would be the game. If this feels bizarre, scary, like totally don't remember any of this shit, go back into the textbook and read that section. I think it was section 2.8. I can
This one's in homework 4. It's one of the last questions.
Yeah. And there are more examples of things like this. There it is. I believe. Change. Oh, maybe it's in 2.8. Yeah. So, right. So here's an example problem in the textbook where they work through what is essentially the same problem we just did. They take the limit that defines the derivative and they calculate it everywhere they can. They split it up by considering x's which are greater than 0 and x's which are less than 0. If x is greater than 0, then the absolute value of x is just x, and the absolute value of x plus h is just x plus h. If x is less than 0, then the absolute value of x is negative x. And so you end up with these two separate things, and then they look at the definition. This is the part that is relevant. So they compute left and right limits separately. They get 1 and -1 here. So they conclude that f primed of 0 does not exist. So this is the game, right? This is the game you want to get a little bit comfy with. Also, this theorem makes a great true-false question. But I think, let's see, yeah, the converse to theorem 4 is false. That's important to remember, right? So if you're differentiable, then you are continuous. However, if you are continuous, you're not automatically differentiable. And so there's a little bit of a discussion here about what it means to be differentiable. Hard corners on the graph are the things that ruin it, but when you need to show it, it's going to mean showing that the limit defining the derivative does not exist. meaning that the left and right limit are not equal to each other. So this. Another way you can do this sort of thing is with piecewise functions, right? I could define a function piecewise and ask you, is it differentiable at the point where I stitch them up? And unless you stitch them up just right so that it's smooth, if you stitch them up like this, or maybe you've got a smooth piece here and a smooth piece here, but when they join, the join isn't smooth, you can run into the same sort of problems. Okay. There were a couple other questions here, yeah. 25 and 26 from the homework. So 25, I'm happy to revisit it. Yeah, this is one that Angelica was talking about earlier, and we have done it once before, but it's tricky, and I think I made a little mistake when we did it the first time. So let's take a fresh look at that. Right, the sine or the cosine first, it doesn't matter. Cos theta. So here you've got three functions all multiplied together. So the application of the product rule isn't immediately obvious, but you need to split it into two pieces. So I'm going to split it like, well, I'll split it the same way we did last time. Split it like this as a piece and this as a piece. So according to my product rule, I should differentiate the first piece and leave the second piece alone, and then add that to the first piece, times the derivative of the second piece. And you notice on all of these problems, I write out kind of schematically what I'm going to do with the prime notation before I actually calculate derivatives. That can be a really good strategy, especially here where one of these derivatives is a little bit complicated. And this is a cos. All right. So this guy on his own is a product rule thing. So there's a little product rule within our product rule here. That's what's going on. So him, I'll differentiate the theta. He differentiates to 1 and leave the cos alone. Then I leave the theta alone and differentiate the cos. Derivative of cos theta is negative sine theta. This sine theta just comes along for the ride. And then over here I have theta cos theta times the derivative of sine theta is just another cos theta. So two product rules in one. You could stop here, but this is one of those cases where there's a lot of simplification you can do. And I wouldn't stop short of distributing the sign and looking for simplification. So here I'll have sine theta times cos theta minus theta times sine theta times sine theta. That's minus theta sine squared theta. And then I have this piece plus theta cosine times cosine is cos squared theta, like that.
I got lost somewhere, I'm sorry.
Well, that's okay, yeah, let's take a second. We can go back a step. So are you comfortable to here?
So theta is to 1 when it's primed. Cos theta primed is negative sine theta. So why did you bring down 1 cos theta plus theta times negative sine theta?
I'm doing a little product rule in here. So these parens right here, what's inside them is the result of the product rule applied to this piece. So I differentiate theta and I leave cos theta alone. And then I add that to what I get when I leave theta alone and differentiate cos theta. So if this is f and this is g, then this is f prime times g plus f times g prime. I'm not writing it that way because we've already used the symbol f to mean something in particular. But yeah, so everything in the big bold parentheses here is coming from this derivative here. And it's a product rule thing where theta is the first function and cos theta is the second function. So differentiate the first, leave the second alone, plus leave the first alone, differentiate the second. The 1 is the derivative of theta, and the cos theta here I leave alone. Then here I leave theta alone, and the negative sine theta is the derivative of cos theta. You seeing it?
Yes, I'm just doing it myself now. Thank you so much.
No problem, no problem. This is sneaky stuff. Then from here, we distribute the sign. I get sine theta times cos theta from the first piece. And then this minus is this minus, and I have theta times sine theta times sine theta. That's sine squared theta. There is one more little thing we can do here. If I factor out this theta, then what's left is cos squared theta minus sine squared theta. And that is a place where we can make use of an identity. Because cos squared minus sine squared is cos 2 theta. Tybee, yes, the derivative of theta taken with respect to theta. So if I differentiate this, think of it, it's like differentiating x, right? The derivative of x is 1. The only difference here is we're using the variable theta instead of x. So yeah, the derivative of theta is 1. Or dd theta of theta is 1.
So we keep the theta, negative sine theta together to multiply by sine theta instead of doing each one individually?
Say that again. I'm not sure I fully understood.
Yeah, me either.
These together?
Yeah, you keep those two together to multiply by sine theta. You don't actually.
So I'm distributing to this and to this. This is a monomial. This is really just one term because it's all being multiplied. So this is theta times negative sine theta. And I'm thinking of that as negative theta sine theta. And then I hit it with the other sine theta. That gives me the negative theta sine squared theta.
Because we would multiply, for instance, inside that parentheses with order of operations. First, if those were numbers, it would make more sense. Thank you.
Yeah, that's precisely it. It's an order of operations thing. So then if I'm feeling fancy, the last thing to do here is to apply my double angle formula for the cosine function. If you happened to not remember this, I'm not going to beat you up for it, but cos squared theta minus sine squared theta, that's cos of 2 theta. And while it might not be hugely important here to use your double angle identities, they will be hugely important in Calc 2. So it's something that I'm going to kind of ratchet up as we go through the semester. We will use them more and more. But at this point, right now, I would not beat you over the head or anything if you didn't know this.
So cos squared theta minus sine squared theta equals cos 2 theta.
Yep. Yeah, while we're here, let's talk about the other trig identities. Important ones first, the Pythagorean identity and his two cousins. These you must know. I just memorized the top one and then cook these other two up as needed. So to go from the top one to the middle one, I divide everybody by cosine squared. And to go from the top one to the bottom one, I divide everybody by sine squared. But you got to know these. These are definitely the most important trig identities. Next up in terms of importance are the double angle identities. Those are these guys. And we use the first one more than we use the second one. There are other identities out there in the universe. There are half angle identities. And my preferred way to remember those is like this. But we call them a half angle identity because the inside of the trig function on the left is half of the inside of the trig function on the right. But really a half angle identity and a double angle identity, they're essentially the same animal. But yeah, these are the trig identities that you will need in calculus. And right now, I definitely expect you to be masters of these three, comfortable and aware of these, and at least aware of these. And we will use these guys more and more as the semester goes on. We'll be using these guys right from the start. Okay, there were some other problems requested, right? We wanted to do 26. Let's take a look at that. Yeah, that's a good one. Find the equation of the tangent line to that function at 0, 4. I'll leave these up here for just a second longer in case anybody is writing them down. Here, let's put that there so I don't need to block the camera. Okay. So, homework 526. Just write this down. Find the equation of the tangent line to y equals 4e to the x cos x at the point 0, 4. Okay. So let's do it. In order to find the equation of that tangent line, I need y primed, which means I need to differentiate this. Now, here's how I would think of it. The constant, remember, pops out. Constant multiples always pop out of derivatives. So we can forget about the 4. We just bring the 4 out front and then differentiate e to the x cos x. That derivative is a product rule derivative. So this is going to look like 4, and then I'll open a big bracket. I differentiate e to the x and leave cos x alone. Plus, then I leave e to the x alone and differentiate cos x. That's my kind of schematic. The derivative of e to the x is e to the x, so that's e to the x cos x plus e to the x times the derivative of cos x is negative sine x. I can factor an e to the x out. And what's left inside is just cos x minus sine x. And I think that's as nice as anybody could ever want that derivative. So then what we want to do with this is find the slope of my tangent line, which means I need to plug in a. A is this guy. It's 0. So the slope of my tangent line I'll remind you this notation, it's y prime evaluated at x equals 0, which is 4e to the x times cos x minus sine x evaluated at x equals 0, which is 4e to the 0 times cos 0 minus sine 0. E to the 0 is 1. Cos 0 is 1. And sine 0 is 0. So this is 4 times 1 times 1 minus 0, or just 4. So now I have my slope, and I have a point. So if I want to write down the tangent line, it's y minus the y value of my point, which is 4, equals m, which is 4, times x minus the x value of the point, which is 0. So this is the same as saying y minus 4 equals 4x, or y equals 4x plus 4. Like that. Any questions on this one? Something short there, something less. Yeah, no problem. Yeah, this is all such good stuff. Okay. Where are we with time? This is 9:45 to 11:05, right? So we have time to do one more-ish. Yeah, time to do about one more. Any last-minute questions or problems that are bugging you? Anything you guys would like to get a little nudge or hint on before we sign out for the day? No, certainly not. Miranda asks in chat here if we did all the work. So if I asked you to use the limit definition to calculate some derivative, if you do all that, you do it all correctly, and then check your work using the differentiation rules, I would not take off points for that. No, that's excellent. I strongly encourage that if you have time. Yeah, I would never penalize you for checking your work. Let's extend homework 4. Oh, okay. Angelica, I think I've already done that. I saw I didn't do it for the whole class, but I saw your email requesting that yesterday, and I went in and made sure that was open. Oh, but it was only open to the 19th. So I will do that right after I sign out here.
Thank you.
All right. Any other problems you guys want to look at, or anything you want to talk about before we wrap up here?
No, sir.
Sounds like we're feeling pretty good. Okay, so work hard on the homework and study guide over the weekend. If you didn't get those done, that's all right. You got the time now. Try to be prepared for the exam. It will be on Monday during our normal class time, and I will post one more announcement to Canvas explaining exactly what to do once I have everything set up in Canvas so that you can take a look. Anybody still having honor lock issues with their computer? I know I had a couple people reach out to me about potentially getting a loaner laptop from the college, and I tried to reply to those. If you're still having any problems with that, or if the college has not complied yet, please let me know, and we can make that go also. All right, I will go ahead and end the meeting here for today. I will have my normal office hour from 1 to 2, so if there's any lingering questions or anything you want to talk about, come see me there. Otherwise, I hope you guys have a lovely weekend, work hard, and make sure you watch Canvas for that last announcement about the exam so you can get in and get the exam taken care of on Monday. All right?
Thank you so much.
Yeah, take care, guys.
Thank you.
You're welcome.